Hi students, this is a subchapter from your topic metals and we will be looking at metals extraction. Okay, to recall what we have learned for metals, we have actually looked at the metal reactivity series, how to rank the metals according to their reactivity, how these reactive metals react with cold water, steam and acid, how do displacement reactions occur, what are the observations that we have to write in displacement reactions, the thermal decomposition of metal carbonates, and then we will be looking in this video metal extraction in particular iron, as well as other metal extractions with regards to using carbon and hydrogen as your reducing agent. Okay, last but not least, we will be looking at rusting and recycling of iron in detail. Okay, so reactive metals, they do not exist as pure metals in the nature. Okay, because they are reactive, they will react with elements found in the environment, such as oxygen to form the oxides, sulfur to form the sulfides, and they will also react to form carbonates. So they do not exist as pure metals. Okay, the oxides, the sulfides, and the carbonates, we call them metal ore. Okay, non-reactive metals, right? They exist as pure elemental states. So they exist as just the metal by itself. Examples of non-reactive metals, we have learned silver and gold. Okay, so to obtain these reactive pure metals, what we need to do is we need to extract them from their ores. Essentially, we need to remove the oxygen. And how do we remove oxygen? We use reducing agents such as carbon, carbon monoxide, or hydrogen. Okay, this table over here gives the common name of the metal ores that are found naturally in the surrounding. Okay, so very commonly they will test us on bauxite, which is my aluminium metal ore, as well as hematite, which is the iron metal ore. Okay, these two is just good to know. Okay, so we will look at iron extraction in detail. Okay, so the main form of iron ore is called the hematite. Okay, hematite consists of two things. Consists of iron 3 oxide, which is my Fe2O3, and then there's also sand and clay. So these metal ores are dug out from the earth itself, and that's why it is always mixed with sand and clay. Okay, so the raw materials that we need to add in when we do iron extraction, definitely we need number one, the hematite. And remember, this is iron 3 oxide, Fe2O3. Okay, other raw materials include coke, which is carbon, and limestone, which is calcium carbonate. And then we also need a blast of hot air, mainly to supply oxygen. Okay, so iron is extracted from Fe2O3 from the hematite in a blast furnace commercially. So this picture over here shows a picture of the blast furnace. Okay, a few things we need to take note. The raw materials, your hematite, this one usually comes with sand and clay, coke, as well as limestone. These starting materials, the raw materials, we put it at the top of your blast furnace. Okay, and then what's going to happen is we also have to pump in hot air. So we blast in hot air over here, and then essentially chemical reactions will take place inside, and at the end of the reaction, your molten iron, right, will sink to the bottom, and then this is extracted out. So this iron will be pure Fe, right? It is no longer the Fe2O3. Okay, and then there is a product that comes out from your blast furnace, and it is called the molten slag. Later we will see what is it exactly. And then there will be some gases that are formed. Okay, the gases are not used in the reaction, and then they are also formed, and these will come out at the top as waste gases. Okay, so generally, where does the substance enter and where they exit from your blast furnace, we have to know. Okay, so when we blast hot air in, good to know, or actually we have to know that hot air is the source of oxygen. So this oxygen basically will react with my starting material carbon. Okay, and then our common waste gases are, example, your nitrogen, because when I blast hot air in, air is 78% nitrogen. So nitrogen doesn't react, it comes out as waste gas, as well as some of the gases that are being formed because of carbon and oxygen reaction. We have my CO and CO2. So these waste gases will come out somewhere in the middle to the top part in your blast furnace. Okay, next part we will look at the reactions that take place in your blast furnace. Okay, so over here, these are the chemical reactions that's taking place in your blast furnace. Essentially, there are 5 reactions that we have to know. Okay, 1, 2, 3, 4, 5. Okay, so remember our starting material. Okay, let me just type it out. Our starting material, we have hematite, which is essentially Fe2O3, my iron ore, plus sand and clay, like the impurities. Okay, I also add in carbon, which is coke. Okay, and then I also add in limestone, which is my calcium carbonate, CaCO3. All right. Okay, so let's look at the start. Uh, First of all, the first reaction involves my carbon, the coke. Okay. Oh yeah, sorry. One more starting material that usually comes with carbon. We have the hot air. So hot air's main function is to supply oxygen. Okay. So first of all, we always start off with the carbon. Carbon will react with the oxygen from the hot air to form carbon dioxide. Okay, and this carbon dioxide will react with more carbon that I add in to form CO. Okay, please remember this, those of us who have done redox. Carbon monoxide, this is the strong reducing agent. Okay, so CO is the main reducing agent in iron extraction, and CO is used to extract the iron from the Fe2O3. Okay, CO is used to reduce the iron from the Fe2O3, your iron 3 oxide. Okay, so just to balance out your equation, right, we have 3CO plus Fe2O3 give me iron, pure iron, and carbon dioxide gas. Okay, do note the state symbol for your pure iron. The state symbol is molten, so this is hot liquid. Okay, and then molten iron, it goes all the way to the bottom of the blast furnace, and then we collect it up. Okay, so just now I covered this Fe2O3. I also covered carbon. I also covered the hot air. So we are left with essentially 2 substances. My sand. So sand is actually an impurity. It is SiO2. Okay, and then we also added in the calcium carbonate at the start. So the 4th and 5th reaction will help me or will tell me what happened to these 2 products. Okay, these 2 substances. Okay, so next one, why do we add in the limestone? Limestone, the calcium carbonate will decompose to give me CaO plus CO2. Metal carbonate, whenever you see a carbonate, it breaks down into the carbon dioxide and the oxide is left behind. Okay, so by now we have to know, right? My calcium oxide, this is a metal oxide. Okay, let me write that down. Calcium oxide is a metal oxide, so it's basic. Okay, the nature is basic, right? Okay, this metal oxide combines with the impurities from the ground, so the sand that we get from when we dig out your hematite. This is the sand. Okay, this sand is my silicon dioxide, which is a non-metal oxide. Okay, my silicon dioxide, SiO2, is a non-metal oxide, which is acidic. Okay, so what's going to happen is the base reacts with the acid. Okay, so my calcium oxide is a base. It reacts with silicon dioxide, which is an acid. In nature, it will give me everything combined together to form the CaSiO3, which is my calcium silicate, which is also known as slag. Okay, capital S because silicon is an element by itself. Okay, so this molten slag is collected on top of the molten iron. So my molten iron sinks to the bottom, slag because it's lower density floats on top. And then we use this slag as one of the byproducts, right, to make roads and cements. Okay, and then because there's a lot of gas that's being produced, my CO2 and my CO, so these gases, if they are not 100% used in reducing, it will come out as waste gas at the top of the blast furnace.